Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder if your feelings really change over time, and how much your partner's feelings might be tangled up with yours? Well, this new study dives deep into exactly that. They're asking big questions about how our emotions shift and sway, especially when we're in a relationship. Think about how much your mood can change from one day to the next, sometimes even hour to hour, and then imagine how your partner's mood might be influencing yours, or vice versa. It is like a dance of emotions. So, what they're doing here is trying to build really detailed maps of these emotional changes. They use a fancy approach called dynamic systems modeling. Instead of just looking at a snapshot of how someone feels, they're tracking those feelings over a period of time. It's like watching a movie of emotions rather than a single photograph. They start with some basic ways to look at change, like simple straight lines showing improvement. But then they get really interesting. They move to a method that lets them see how things change continuously. Imagine your mood isn't just going up or down at specific measurement points, but it is a smooth flowing process. They can even account for random jitters or changes that aren't just measurement mistakes, but real shifts in your emotional state. Let's imagine someone named Alex. Alex is going to therapy, and they're tracking their feelings every week for 21 weeks. This gives the researchers a really rich data set to play with. They want to understand how Alex's feelings change during therapy. At first, they think about a simple idea. Maybe Alex's feelings just steadily go up like a straight line here. Is Alex's feeling at any given time? 0 is where they started, is how much their feelings increase each week, and is just random little blips or errors. If you imagine plotting this, it looks like a nice steady upward climb. But is that realistic? Does everyone's mood just go up in a straight line? Probably not. The researchers realized that while Alex's feelings might go up linearly, other people might have different starting points and different rates of change. Maybe someone who starts feeling really low gets better faster, or maybe someone who is already pretty happy doesn't change as much. This is where they introduce the idea of individual differences. Now, means we're looking at person I, so each person has their own starting point 0 and their own rate of change. This is like saying, okay, the general trend might be upward, but everyone's journey on that trend is a little different. When they show this for multiple people, you can see these slightly different starting points and slopes. Some are higher, some are lower, and they move at different paces. It starts to look more like real life. But here is where it gets even more interesting. What if the rate of change isn't constant, but depends on how someone is feeling right now? If you're already feeling pretty good, maybe your mood doesn't jump up as much as if you're feeling really low. This is called state-dependent change. In this model, how you feel now depends on how you felt last time. 1 multiplied by a factor A plus a constant boost B. If A is less than 1, it means the effect of your previous mood is dampened, so you don't just keep going up forever. It makes more sense. This plot shows a curve that starts to level off. It's a more realistic picture, suggesting that change can slow down as you reach a certain point. Now, all of this has been looking at changes that happen from one measurement to the next. But what about in between? Do our feelings just stay flat and then suddenly jump when the researcher measures them? Or do they change smoothly? Moment by moment, the researchers argue that feelings likely change continuously. Scroll plus foo, they use differential equations to model this continuous change. Here, overrepresents the rate of change of your feelings at any exact moment. If A is negative, it means that if your feelings are high, the rate of change slows down, and if they're low, the rate of change speeds up, pulling you back towards a moderate level. Think of it like a thermostat, it corrects itself. And on top of that, they add system noise. This isn't just measurement error, it is like random life events affecting your mood. A sudden headache, a nice compliment, a car cutting you off. These things can cause fluctuations. This figure shows how much more realistic the data looks when you account for these continuous changes and random ups and downs. To actually estimate these complex continuous time models from real data, they use something called a state space framework. It is like saying there is an underlying true feeling process that we can't directly see, and our weekly measurements are like imperfect glimpses of that true process. They use a powerful R package called ctsem to do all of this. It is like a sophisticated toolbox for building these dynamic models. They show how to set up these models in the software. It involves telling the program about the observed variables, the hidden internal states, and the rules that govern how these states change over time. When they first tried to predict Alex's feelings using just the model's general rules, it is not super accurate. See how the red dots are the actual feelings, and the red line is the model's best guess. There's a big gap. But when they let the model learn from some of the actual data, the predictions get much better. This shows the power of the model to adapt to real-world patterns. Now, a crucial part of science is checking if your model is actually any good. They fit a wrong model, a simple linear one, just to see how you'd spot that it is not working. They set up a model that assumes a simple linear growth, just like we talked about at the beginning. Look at this figure. The model is supposed to predict the lines, but the dots, which are the actual data, clearly don't follow those predicted lines. There is a pattern they're missing. This plot shows you the leftover patterns in the data that the model didn't explain. High peaks here mean the model missed something important. This is where the real detective work happens. They see the linear model isn't good enough. They notice that the way feelings change seems to depend on how the person is feeling initially. So they add state dependence. After adding state dependence, look at this. The red line model prediction is now much closer to the black lines and dots actual data. The model is finally getting it. And when they add system noise back in, the leftover patterns in the data become almost zero. This means the model is doing a really thorough job of capturing how feelings change. But what about couples? Your feelings don't exist in a vacuum. Your partner's feelings can influence yours, and yours can influence theirs. This is where things get really fascinating. Scroll 111 plus 122 plus 1 plus 111 plus 122. Scroll, they write equations that describe how Alex's feelings, 1, are affected by their own feelings, 11, and their partner Robin's feelings, 122, and vice versa. They can even look at how their random mood swings might be correlated. Maybe a stressful day affects both partners. This shows predictions for two couples. You can see how the model is trying to capture the intertwined emotional lives of both partners. And people are still different. Not only do we have different starting points, but the way our emotions influence each other might be different. Maybe some couples are more tightly coupled emotionally than others. Here, you can see how different couples might have different patterns of emotional interaction, even with similar underlying rules. What about things like therapy sessions or major life events? How do they shake things up? This plot shows the impact of therapy sessions. See those little upward jumps? That is the model showing how a therapy session gives Alex a boost, which then plays out over time according to the established emotional dynamics. Sometimes an intervention doesn't just give a quick boost, it can create lasting change. Imagine learning a new skill. It doesn't just help you for a day, it changes you long term. They have ways to model that too. And the really mind-bending part is when the rules themselves change over time. Imagine a relationship where, at first, partners don't influence each other much. But as they spend more time together, they start to affect each other more deeply. So, what is the big takeaway? This research isn't just about understanding emotions. It is about having the right tools to really see how emotions work over time. Both for individuals and for people in relationships, they've shown how to move from a simple theory to a complex but understandable model. This is the core of scientific progress, right? You start with an idea, you build a model, you test it against reality, you check how well it fits, and then you refine it. It is an iterative dance between theory and data. While they focused on couples' feelings, these principles apply everywhere. Think about how your mood affects your work, how stress affects your health, or how learning changes your brain. All these things are dynamic systems. It means we can start to understand the mechanisms behind emotional change. Instead of just knowing that therapy works, we might start to understand how it works. Moment by moment, day by day, it gives us a more nuanced view of ourselves and our relationships. It highlights that our feelings aren't static. They're constantly evolving, influenced by ourselves, our environment, and the people around us. This is a really exciting direction for psychology. It moves us away from simple cause and effect or static descriptions towards a more dynamic, interconnected view of the human experience. They've given us a toolkit to explore these dynamic landscapes with more clarity. What do you think about these ideas? Are your emotions a constant dance for you too? Let me know in the comments below. And if you found this breakdown helpful, give this video a like, subscribe to RUBIN'S Mind Lab for more science explained simply, and hit that notification bell so you don't miss out on our next exploration of the human mind. Thanks for watching.